multiprocessing threads. So in this class, we are going to discuss about multiprocessing and multitasking. So what do you mean by multiprocessing? The first we will discuss with what do you mean by multiprocessing. So multiprocessing is nothing but what? It's the ability to execute multiple processes simultaneously. So that means multiple process will be executing. Okay. So now when you are executing the multiple processing, as the name indicates, multiple processing. So what it involves there? So it is going to involve the multiple processor. So it is capable of performing the multiprocessing. So it are known as multiprocess system. So now, as the name indicates, it's a multiprocessor. So this process multiple CPUs. Okay, so this particular type of processing which you are going to do, so that is going to process the multiple CPU and can execute multiple processes simultaneously. Okay, so you are going to have multiple process, multiple CPUs will be there. So if you take the dual core like that, cores will be there, right? So you're going to have core 1 and core 2 like that it will be having. So like quad core if you have, so it will be having 4 cores, core 3, core 4 like that. So each individual core will be executing each individual process here. So this is nothing but what? So your core is nothing but the processor. Okay, so here this is nothing but the processor. So inside a single CPU, you are going to have 4 cores. That means 4 processors we are going to have. So 4 processor will be running individual process. Okay, so then that type of processing is called as multiprocessing. So these type of systems process multiple CPUs and can execute multiple processes simultaneously. So now, whenever you're running a multiple process inside your CPU, so who has to schedule that one? So that has to be scheduled by your operating system. So next comes the question. So what is this ability? So the ability of an operating system to have multiple programs in the memory. So, okay, so the ability of the operating system to have multiple programs in the memory, so which are ready for execution. Okay, so that is referred as multiprogramming. So now who is scheduling? Your OS is scheduling. So where it is going to schedule? So whenever you want to run the different program, the program has to be first loaded into the memory. So first load into the memory. So now when it is loaded from memory, what it indicates? It indicates it's ready for execution. So if we are loading it in the memory, it is going to be ready for execution. So when it is ready for execution, then that type is referred as what? Multi-programming. Okay. So in simple terms, it is nothing but what? Its ability to execute multiple processes simultaneously, and it's going to have it is going to have, or it is going to process multiple CPUs, and it is going to execute the multiple process simultaneously. Okay. So the next type is multitasking. Okay, so we discussed about multiprocessing. Next is multitasking. So now, what is multitasking? So if multitasking is nothing but it's an ability of the operating system to hold multiple processes. So the operating system is going to hold the multiple process in memory. So the multiple process will be there in memory. Okay. So now, when it is in memory, when the multiple process is in the multiple process is in memory. So when multiple process is in memory, so depending upon the time quantum, so each process will be scheduled. So that particular process will be switching depending upon the scheduling technique which you are going to use. Okay, so in this particular type of in this type that is multitasking, so it is nothing but it's an ability of an operating system to hold multiple processes, okay, in memory, and it is going to switch the processor from executing from one process to another process. Okay, so you're going to have the processor. So depending, so you're going to have the memory, right? So it is going to have the memory. So inside the memory, you're going to have P1, P2, P3. So it is going to schedule it. So switch the processor. Sometimes P1 will be running, sometimes P2 will be running, sometimes P3 will be running from one process to another process. So this is called as what? Multitasking. Okay. So who is going to hold the process? Your memory is going to hold the process. So who is going to schedule that one? Your operating system is going to place that particular program into the memory. Okay. And it is going to switch from executing one process to another process. Now, when you are doing all these things, so when you are switching between the process, what it is involving, what it is going to involve is the next question. So basically, it involves the context switching first. Okay. So next, it has to involve your context saving. So next it has to do the context retrieval. Okay, so as you people already know that what do you mean by context switching? Okay, context switching is nothing but what? So if one process is running, so whenever the time quantum for that particular process has been came, what I need to do, I had to save at what part it has been uh, interrupt has been arrived. So and then I have to release the CPU to the next process. Okay. So once after that one, so once this particular process 2, if we take P1 and P2, so after P2 completes its execution, so it has to release the CPU to P1. So P1 will continue from where it has been stopped. The P1 is going to start from where that particular P1 is going to stop. So it is similar to your subroutine or function, which we can take it as an example. Okay, so when you are running your function inside your program, what you are going to have, the function will take part to the different part of the program. Okay, so now so it is going to have, it has to say what has been happened in your main program. So then the function will run. After completion of the function, it is returned back to the main program. So that will be returned back to your main program. So what, from where it has to start again, it has to start from again where even previously it has been stopped. So previously it has been stopped till the function is called. Okay. So once it completes its functionality in the outside of your main program, so it is going to return back to the main program. So after return back to the main program, from there it is going to start again. So that is the simple example what you can give for your context switching. Okay. So next is your context saving. Okay. So what you have to do. So whenever the context switch is going to happen. Okay. So whenever you are going to switch the execution of context from one task to another task. So as I told you now, so when the task or process switch happens, so the current context or the current process which is running, so that should be saved first. The current context of the execution should be saved, and when it comes back, it has to retrieve it the later point of the time when it is needed. Okay, so that is what the context saving you are going to have. Context saving is nothing but what, at what part that particular switching is going to happen at that particular point of time. You have to save all the details of the current running process before releasing that particular releasing the CPU to the other process. So next, once you have completed that one, so what next? Once you have once the context switching has been done, so after completion of the next context, so it has to come back to the previous context which has been stopped there. So this particular term is referred as context retrieval. So in this particular context switching, what will happen? The context has to be executed. Okay, so is retrieved from the saved context list. So it will be executed from the saved context list. So that is referred as your context retrieval. So that is referred as your context retrieval. Okay. So the next is context switching. So whenever the context switching is going to have, so typically if we take this particular scenario, so this is one scenario where you are going to have, so you are going to have two different process running. One is process 1 and another is process 2. Okay. So when process is running, so assume that so delay in execution of process to happen due to context switching. So it will be, this particular process will be in idle state at that time. So basically what will happen here, so your process will go into the waits in ready queue. So first it will be in running state. So once the context switching comes, so what the running state will go? So the running state which is there, that particular process will go to the ready queue. So waits in ready queue. Now after some part of the time, if that another process which is running, if it is not releasing, if it is not released the if it not released that particular context, so what will happen? It will go to the idle mode. Okay, so it will go to the idle mode, that is not working. So now, so why the delay in execution is, why it is going to the idle state is the next question. So why it is going to go into the idle state? So the idle state is going to go, so since it is going to have the delay in execution of process 2. So this is going to happen due to what? This is going to happen due to the context switching. So this is going to happen with respect to the context switching. So now, so here the execution, whenever the context switch comes, what will happen? The context switches from execution is going to switches from process 1 to process 2. So when it is switching from process 1 to process 2, what it has to do? So first it has to save all your current construct in PCB. save all your current context in PCB, that is your process control block. So you're going to have the process control block. So there you are going to save all your context. So at what part that particular process has been stopped. So now, so other, and second one is you have to perform other OS related operations to context switching. So other OS related operations you have to perform. So the two related to context switching. Next, once it is done, you have to reload the context for process 2 from PCB1. Okay, so that has to be taken place. So this is for PCB2. So then process control block for process 1, it will be there. So you are going to reload the context for process 2 from process control block. So because it has to run the process 2 next. So first, if it has to run the process 2, first it has to be reload to where? So it has to reload the context for PCB process control. It has to reload the context for process 2 from where? From process control block 1. So now once it is running, okay, so once it is running, again the context after some amount of time, so some quantum amount of time depending upon the scheduling, so it will be given to some process 2. So now what will happen at that time, whenever that particular time quantum is over or some interrupt comes in between, so what will happen, again the context switch is going to happen. Okay, so now, so again whenever there is a context switch is going to happen, the execution switches from where to where? It is going to switch from process 2 to process 1. The execution switches from your process 2 to process 1. Okay, so now, so it is happening due to the interrupt in the system call. So you're going to have the system call. So this will happen due to the interruption of system call. So again, it has to do the same process. Okay, so whenever this context switches happen, first time what I need to do, so your process 2 is going to have its own process control block 1. Okay, so it has to save all its current context in to which process control block. It has to save the current context into PCB1. So next, what is operation it has to do? It has to perform other OS operations which is related to context switching. So other OS related operations which is required, like where that particular register has to be saved. So if it is going to have the dynamic memory location, so it has to be stored in heap. So where the code memory has to be saved and which address it has to be saved. So those things has to be taken care by your OS. So the other these operations will be taken by your OS during the context switching. Once it is done, what I need to load? So I have to load the process 1. Where it will be residing now? So it is going to be residing in your process control block 0. So that it has to be reload that one. So it has to reload the process control process 1 from the process control block. So this is this is the operations which is going to have. So once it is going from, so your process 1 go from idle state to running state. So during that particular time, what will happen to your process 2? The process 2 will be in wait in ready queue. Okay, so the process 2 will be waits in the ready queue, which is going to happen there. Okay, so these are some of the operations which is going to happen. So when doing the context switching with respect to the multitasking. Okay, so the next is you're going to have different types of multitasking. So what are the, let us discuss about what are the different types of multitasking. So the different types of multitasking which you're going to have is, one is your cooperative multitasking. So next is your preemptive multitasking. Okay, so next is non-preemptive multitasking. So let us discuss what do you mean by cooperative multitasking. So types of multitasking is, one is cooperative, preemptive, other is non-preemptive. Okay, so there are three types of multitasking which you are going to have. So in cooperative multitasking, as the name indicates, cooperative. So this is the most primitive form of multitasking. Okay, so now in this particular type of multitasking, what will happen? As the name indicates, cooperative. Cooperative means what? So whenever you have two systems in your home, so assume that your brother and sisters are working out. Okay, so now assume that your brother is doing the work on that particular system. So if you have the cooperation, what you are going to do? So if you have the cooperation, so till your brother completes his work, so you're not going to give the system to you. So you will be waiting till he releases, till he gives the CPU to you. Okay, so that you both are in cooperation. That means here what we are talking is with respect to the process. Okay, so the cooperation here, what is happening is with respect to the process. So here what will happen? So whatever the task you are going to have, so the task which is there in the ready queue, so it will get the chance only if the currently executing task voluntarily relinquishes the CPU. Okay, so whenever your process is going to be released, or a process is going to release the CPU, so only at that time the next process is going to run. So only at that time the next process which is there in the ready queue will get a chance to execute. Okay, so only if the current process releases the CPU. So now in this method what will happen? So whenever whatever the process it is running, okay, so assume that the process is running. So now till it completes, it is not going to release the CPU. So that means what? So the CPU can avail as much time as it wants. So in this particular type of multitasking, the CPU is going to utilize as much time as it wants. Okay, so it is going to utilize as much time as it wants. So now, as the name indicates, cooperative. So here the same thing. So since that particular type of in this particular type of implementation, what happens? So it involves the cooperation of tasks with each other. Okay. So for what purpose it requires the cooperation of the task to get the CPU time for execution. Okay. So cooperation is required here to for getting the CPU time for execution to run the to do what to so execution what you are going to do. So the execution you are going to do on process, since process is nothing but what a programming execution. Okay. So now if the currently executing process task is non-cooperative, so now what will happen? So if that particular process which is running, okay, so assume that not cooperative. So it's normal term. Okay, so if it is not cooperative, so assume that you and your friends are working, right? As the same example, if I take, so if it is not cooperative, what will happen? Even if you ask for the system, it will not leave. Okay. So now, if you are not, if he is not leaving the system, means what? You have to wait till he leaves the CPU. So that means you don't have the understanding. That means you don't have the cooperation. So when you are going to have that one in this particular type, so if that particular task, what we are telling, if it is not cooperative, what will happen? So other task which is there in the queue has to wait for longer duration. So other task which is there in the ready queue, so has to wait. So task which is there in ready queue has to wait for how much time? Till it releases, till the process which is running releases the CPU. So the long time duration it has to wait. So long time to get the CPU it has to do. So that is what happens in your non-cooperative if the process is non-cooperative. Okay. So next type is preemptive scheduling. So now in preemptive scheduling, what will happen? So every process which is there in that ready queue will get a chance to execute. So if we talk about the preemptive execution, so here, so every process gets a chance to execute. So depending upon the time quantum or depending upon the priority. So even preemptive scheduling is going to work with respect to the priority. That is, whenever the high priority task comes, so whatever the current task which is running, so that has to be save its status or context, and it has to release the CPU to the process which is coming next. Okay, which is having the high priority. So now next comes the question, when it is going to get a chance. So we have to ensure that in preemptive multitasking what it is going to do, so we are telling that we are going to get a chance to execute. That means every process has to get a chance to execute. So now how much time that process has to get is the next question. So how much time, so how much time that process has to be dependent, so how much time has to be, how much time the process has to be given, and it is dependent. So that particular how much time that particular process will be given, that depends upon the type of the application, okay, or type of the implementation. Okay, so not application, so it will be type of the implementation which you are going to design that one. So type of implementation of the preemptive scheduling. Okay, so depending upon the type of the preemptive scheduling, so how much time it is dependent, so that we have to give. So as the name indicates, preemptive multitasking. So the name itself is telling that it is a preemptive multitasking. So now what it means, so whatever the currently running task or process is there, So that has to be preempted. So by preempting, what you are going to do? So by preempting, you are going to give the chance to the next process. Okay. So by preempting, you are going to give the chance to the next process or other process to execute, which is there in the ready queue. Okay. So that particular process which is there in the ready queue or high priority task comes in between. So we are going to release, we are going to uh, give a chance to execute for that particular process. So now, when how that particular preemption is going to take place? So there are many reasons how the preemption is going to take place. So that preemption can take place depending upon the time slot also. So that is you are going to have for this particular period of time, this particular process has to run. After this particular time, you have to release the CPU to the next process. So next, after that particular process, another process has to run for this particular period of time. So there you are going to have the preemption. So another one is your time quantum, depending upon the time slots or time quantum which you are going to have. Okay. So other is your priority. So these are the two uh, methods or two scenarios where you have to make use of preemptions. One is your, depending upon the time slots, you are going to preempt the task. Second is your, if your process is having the priority. Okay. So then you are going to release, then that particular process is given the chance to execute. So it is, or it is what the explanation for your preemptive multitasking. So the next type of multitasking is non-preemptive multitasking. So, so in your non-preemptive multitasking, what will happen? So if the process which is running currently, okay, so I think process is running currently. So now till it completes its execution, that means till it completes its operation, so it will not release the CPU. So now, so given the, if we talk about the CPU process terminology, so what you are going to give? So we have to provide you the CPU time. So what, for what purpose it has to be given the CPU time? So the CPU time is given to execute the process. Okay. So till it executes the process, or when it is executing the process, until it terminates. So it has to be waiting for an IO operation to be complete. So what it means? So here it is the process which or task which is there, which is currently given the CPU time, is allowed to execute until what? Until it completes its operation or it is going to terminate. So that means termination means what? It is nothing but it is going to complete its operation, or what it is going to have, or that particular process is going to into the blocked or wait state. So either one of the, or it is going to waiting for an IO operation to be performed. So that particular process is going to have IO operation to be performed. So these are the three scenarios where your CPU time will be given. So until your process terminates. Second is until your process is going to be blocked or wait state. Okay. So next, until it is waiting for an IO operation. So it's still it is waiting for an IO operation. So now if you take the cooperative and non-cooperative multitasking. Okay. So first if you take the cooperative and cooperative and non-preemptive multitasking. So now, so both are similar, but how they are differ in their behavior. So it looks like both are similar, but there is a change. So since what is the reason why they have make this as cooperative multitasking and non-preemptive multitasking. So now how it is behavior is differing between these two is the next question. So the behavior of cooperative and non-preemptive multitasking is going to differ only when they are in the blocked or wait state. So it's going to be differed only in the blocked or wait state. How it is going to be done? So how it is differing in block or wait state, which you are going to have. So what will happen in your cooperative multitasking? So in your cooperative multitasking, what will happen? Currently executing process need to relinquish the CPU. Okay. So it has to release the CPU only when it enters the blocked or wait state. So in your cooperative multitasking. Okay. So whereas in your non-preemptive multitasking, so now it is going to release the CPU only when it waits for an IO. Okay, some IO operation it has to perform. So only when it waits for an IO operation, so it is going to release the CPU. But it is not the case with your cooperative multitasking. So in cooperative multitasking, what will happen? So whenever that particular process enters into the blocked or wait state, so it is going to release the CPU. So but it's not the case with respect to your non-preemptive multitasking. So in non-preemptive multitasking, it is going to release the CPU only when it waits for an IO operation to be performed. Okay, so that's what. So it is going to about your non-preemptive multitasking. So anybody having any doubt in those things? So anybody having any doubt in multiprocessing and multitasking? Okay. So if you don't have any doubt, so move further. So the next step is your task communication. Okay. So now when you are going to have the communication between the between the task. So when you have multiple processes are running, so in the multitasking environment, so what will happen? So multiple tasks or a number of tasks will be running concurrently or parallelly. So here the number of processes are running parallelly. So there, when a number of processes are running parallelly, so one process may require the data from the other process. So they have to make a communication between these between the process. So but at what level is the next question. So whenever a number of processes are running, so they have to make communication, or they have to exchange the message, exchange the data. So where it is required by one, where the data is required from one process to another process. So now when that particular process runs concurrently, so what will happen? We are going to have a number of processes, right? This is if we take this one as process one and this is process two. So when it is running parallelly, what will happen? Sometimes there may be an interaction between them. So there may be an interaction, or they may not be having the interaction. Okay. So only when there is an interaction between the discrete process. So assuming that process one and process two running parallelly. So if they have the interaction between process one and process two, so only during that particular time the communication is required between process one and process two. So if there is no interaction between the process one and process two, so it does not require any communication. So that's what it is going to have. So in the multiple, when you are going to have the multiple task or process which are running concurrently, so each process may or may not have the interaction. Okay, so if it requires the interaction, then it requires the communication between these two processes. So now, depending upon the level of interaction which you are going to give, okay, so the process running on an OS are classified as cooperative process and competing process. So if you take out the interaction, of what type of interaction you are going to have, so the level of interaction which is going to be done. So the process or task running on an OS. So basically they are classified into two types. What are they? One is your cooperative process. Second is your competing process. So let us discuss what you mean by competing process. So in this particular type of competing process, so in this type of model, what you are going to have. So here, as the name indicates, cooperating processes. So cooperating process is nothing but what? So the one process requires the input from the other process to complete its execution. Okay, so you're going to have two processes running. Assume that P1 is running and P2 running. So if assume that if P2 has to complete its execution, so it requires the data from P1. Okay, so it requires the input from P1. So if it is not getting the data from information or data from P1, so this particular process P2 will not be completing. So in this particular type of model, so other process P2 requires the input from other process to complete its execution. So how the cooperation it is going to do? Okay, so the cooperation can be done by two methods. So what are those two methods the cooperation will be done? One, it is through sharing. The cooperation will be achieved through sharing. So other, the cooperation can be achieved through communication. Okay, so now when your cooperation is done through sharing, how the data is exchanged here. So when it, as the name indicates, cooperation through sharing. Okay, so it is going to exchange the data through some shared resources. So you're going to have some shared memory, right thing. So using that particular shared resources. So through that particular shared resources, it is going, those two processes will be sharing the data. So assume that P1 and P2 you are going to have. So you're going to have the shared resource here. So when it is going to have the shared resource, P1 will write the data to the shared resource. So P2 requires the data from P1. So since the data which is there required by the P2 is shared resource, so it is going, the P2 is going to take the data from the shared resource and it will complete its execution. So that means it is going to have the input from, indirectly it's going to have the input from your process one. So that is going to happen there. So similarly, the second type is cooperation through communication. So when it is, Then with respect to the cooperation to communication, so here we don't have any shared data. So no shared resource will be there. So but the data is no data is shared between the process here. But the communication will be done for execution synchronization. So here the communication has to be established with the help of the synchronization. So what is meant by synchronization? We'll come to know next. So how the synchronization will be achieved. So why it is required. So how what are the different type of synchronization mechanism. So I think already you have people have read that one. The same thing we are repeating again here. That's it. So you're going to make us here in the cooperation through communication. So we know that, so here the no data is shared between the process, but they will communicate through execution synchronization. So the next step is your competing process. So here competing process, as the name it is competing. So what they will do, so they will not share resources among themselves. Okay. So but they will share the entire system resources. Okay. So the competing process do not share anything among themselves. So they will not, if we take this process one, process two, so I'm going to have the shared memory, right? So here, so through this one, it is going to sharing. So that is true in cooperating process. But here in the competing process, what will happen? So they will not share among themselves. So here it is not sharing the resources among themselves here. But how they will share that one? But they will share the entire system resources which you are going to have. The system resources such as memory you are going to have. Okay. So like memory, CPU. So these are the system resources which you are going to have. So these resources it is going to share. So now, so what are the, as I told you that, so what it is going to compete. So if we talk about the system resources, the competing process which you are going to have, so that will be competing for the system resources such as what, such as your display devices which you are going to connect it. Okay, such as your display devices and such as your file. So it is going to be connected. So those things it is going to make use of, and the competing process will compete for the system resources. So this is how the multiple task communication is going to be established. So next, the other how the communication is going to be established is concurrently is through interprocess communication. Okay, so IPC refers to the IPC refers to the mechanism through which task or process will communicate with each other. So now, if we talk about the IPCs, so that is interprocess communication. Okay, so that is what dependent. Who is going to be, who is responsible for interprocess communication is the next question. So here, so IPC refers to what? So it refers to the mechanism, okay, through which task or process communicate with each other. So it is one type of mechanism where, so you are going to task or process is going to communicate with one another. So now who is going to do that one? So here if you take the implementation of IPC, so the implementation of IPC is going to happen by the kernel. So the IPC implementation of IP mechanism is OS kernel dependent. So you're going to have the OS kernel dependent. So implementation is going to happen with respect to the OS. So now next comes the question, what are the different mechanisms we are going to have or we are going to adapt by OS? Okay. Some important IPC mechanisms adopted by OS kernels are, which are they? So the IPC mechanisms which are adopted by your OS kernel. So they are nothing but what? One is your shared memory, second is message passing, third is remote procedure calls. So these are the three different mechanisms which are basically adopted by your OS kernel. So what are they? One is shared memory, message passing, remote procedure calls. Okay. So under shared memory, so it is going to have three different types. One is your global variables, second is your pipes. So in the pipes, you are going to have two types. One is your named pipe, other is your unnamed pipe. So you're going to have the named pipe here, other is your unnamed pipe you are going to have. Okay. So next we are going to have the memory mapped objects. So you're going to have the memory mapped objects. So using that one also, you are going to make you are going to make use to do the inter-process communication. Okay. So when it comes to the message passing, okay. So the message passing, it is basically going to make use of message queues. So if you're going to have the messages to be done, you should have the mailboxes. So where the mailbox is going to be used to store the mails. It is going to use to store the mails. Okay. So now whenever you are going to have the mails, okay, so it is going to have the slot. So what is the purpose of having the slot, mail slot? So you're going to have the process running, uh, process is schedule, giving the process is mailing. So now within that particular given a period of time to mail. So it's given a slot, in that particular slot only that particular mail has to be sent. Okay, so that is what you are going to have the mail slot. So next is how it will be done. So you're going to have to provide the signals. Okay, it is going to provide using the signals. So signals will be provided. There are a number of signals which are going to have. So depending upon the type of the signals, so you are going to send the, you are going to communicate with the other process. So the last part which we need to discuss here is remote procedure calls. So another type of communication which you are going to have is your remote procedure calls. Now next, it is nothing but what. So if we talk about your interprocess communication, totally this particular mechanism is what? This particular mechanism is dependent on OS only. So the implementation, so this particular implementation is mainly dependent on OS. Okay, so it is dependent on OS. So these are some of the IP mechanisms which can be adopted there. Okay, so it's mainly dependent upon the operating system. Okay, so I will stop here now. So in the next class, we will discuss about each individual's interprocess communication. So how the shared memory will be implemented in your interprocess communication. So how the, so I think already you have been learnt in your OS concept. So again, it will be a repetition. That's it, nothing else. Okay. So anybody having any doubt, you can ask. So anybody having any doubt with respect to shared memory or with respect to your task communication or with respect to your multiprocessing or multitasking. So what we have discussed now, so we discussed about multitasking and multiprocessing. So in the multitasking, three different types. One is your cooperative multitasking, second is preemptive multitasking, third is non-preemptive multitasking. So when it comes to the task communication, so the task communication is going to happen between cooperating process and non-cooperative process. So and then interprocess communication. Okay, so we have discussed till here. So if you have any doubt, you can ask the doubts. Okay. So anybody having any doubt? So anybody having any doubt? Okay. So if you don't have any doubt, we will wind up the class. So go through these things. Okay. So thank you.